Okay, we're going to take a look at Lesson 6, Composition of Linear Functions. This lesson also gets into some nonlinear functions, but we'll do the linear ones first. So they're going to be giving you a couple of things, f of x, g of x. It could be h of x, k of x, doesn't matter, just a name for them. They are going to be asking you for a combination of these things. Let's say we see something that says f of g of x. What that means is the f is the master function. So you're going to take your f of x function, you're going to rewrite it, and anywhere where you see a variable, you're going to leave some brackets. And into those brackets, you are going to stick that g of x. So it will be x minus 2 in here. Then you're going to do the math, which just means you're going to distribute that 4 over everything, and you will end up with 4x minus 8 on this. Okay, so one function. You are going to see the other way, which is g of f of x. Now in this case, the outside function g, this is the master function. So in this case, you're going to leave yourself a bracket where you see that x. You're just going to put in the rest of it, minus 2. In there, you're going to put your f of x, which is 4x. Okay, that's as simple as you can get, so your final answer is just going to be 4x minus 2. And as you can see, it's a bit different from the one above. If you ended up getting the exact same thing, you would have what's called a commutative function, or a commutative composition. That's not very common, however. So let's take a look at something that's a little bit more complicated. And let's make it a nonlinear function. Let's make a different color here. And let's pick ourselves something like, we'll give ourselves f of x as a line. And we'll make it f of x. This doesn't like it, by the way, when I'm recording, so that's why things are moving pretty slowly here. Let's make it x plus 1. And then let's make our g of x, we'll make that a quadratic function. So let's make it, for example, x squared minus 2. Okay, so in this case, let's do our f of x first. F of g of x. So in this case, the f is the master function, so we're just going to put brackets around the f. We'll add the 1 here. And in there, we're just going to stick our x squared minus 2. Okay, because that is going to be our g function. Now make it look pretty, do the math on this. You'll end up with x squared minus 2 plus 1, so it's going to be minus 1 altogether. Where the trick comes in is when you have to deal with the other direction. So g of f of x is going to look like this. In this case, the g is the master function, and so what you're going to do is you're going to put brackets instead of that x squared, and you're going to put your squared on the outside of this, okay? Then your minus 2. Now inside here, you're going to have to put x plus 1. And you are going to need to remember that what that means is x plus 1 times x plus 1, okay? And you're going to need to use your FOIL rules, etc., which means you're going to go x squared, the outers plus an x, the inners plus another x, and then finally the last terms is going to be plus a 1, and then minus a 2 here. Let's move this up a little bit. Okay, so just consolidate this. These two, of course, are going to join together, and these two can be joined together. What you're going to end up with is x squared, and then I believe we'll have a 2x, and once again we've got a plus 1 and a minus 2, so it'll be a minus 1, and as you can see, it's really quite different from the above one right here. Okay, once again, if you get the exact same thing, it's commutative. You will not end up getting that when you have a nonlinear function. All right, if you've got any questions, write it in your bit paper and let me know. Bye.